Venn diagram is also one of the ways that you can represent a set. Okay, it is a pictorial representation of set. For example, in this Venn diagram, universal set is represented by a rectangle. Okay, so this is your universal set. We have, I will draw 4 Venn diagrams in this video. So this is the universal set. It is represented by a rectangle. And any set other than the universal set, any arbitrary set is represented by enclosing curve. Preferably it is a circle. Maybe I won't be able to draw circle in some cases, but it's preferably a circle. So any arbitrary set using enclosing curve and all within the boundaries of the rectangle of universal set. For example, A is 1, 2, 3, 4, 5. So I'm going to draw like this. So this is A. This is a A. This is how A is represented. So all within the boundaries of the rectangle of universal set. So A is inside this rectangle. Likewise, any arbitrary set, it has to be inside the rectangle, because every set is a subset of universal set. Every set is a subset of universal set. If a set is a subset of some other set, it will be in your Venn diagram, it will be completely inside the superset. For example, in this case, C has 5, 8 and 9, D has 5, 8 and 9. So D is a subset to C. So let me draw C. C will have 3, 4, 5, 6, 7, 8, 9, 10. All of this will come under C. This is the set C. Now D is 5, 8, 9. So this is D. Okay. This is C. This is D. B is 3, 4, 5, 6, 7. So B must include 3, must include 4, must include 5, 6 and 7. So I draw B like this. This is my B. So B is inside universal set because B is a subset to universal set. And A and B, it's not like any of them is a subset of one another. They have some elements in common and some elements that is exclusive to A and some elements that is exclusive to B. 1 and 2 is exclusive to A, 1 and 2 is not present in B. Similarly, 6 and 7 is exclusive to B, 6 and 7 is not present in A. In this case, A is 1, 2, 3, 4, 5. And E is 8, 9, 10. This is A and this is E. A is 1, 2, 3, 4, 5 and F is 3, 5, 2, 4, 1. So both have same elements. So they are equal sets. A and F are equal sets. This is how you will represent A and F. Okay, both are equal sets. So their Venn diagram is just one circle, and this one circle represents both A and F both. So this is A and F both. So I have taken 4 cases of 2 different sets. You can draw all of the sets A, B, C, D, E, F. You can draw all of the sets in one diagram also, but it would become very messy. That's why I have taken 4 cases separately. And these cases are, if you look at this, none of the 2 sets, neither A is a subset to B, nor B is a subset to A. There are some elements in common, however, in this case. Similarly, in this case, if you can see, neither A is a subset to E, nor E is a subset to A. But they don't have anything in common also. So they are you can see here there is some part of this area. Within this area, there will be those elements that are common to A and B. But these two circles are completely separate. They do not intersect with one another. If there is nothing in common between A and E, there is nothing in common, then these type of two sets are called disjoint sets. So A and E are disjoint. A and E, A and E are disjoint sets. A and E are disjoint sets. In this case, D is a subset of C. A set is subset of another set, then it is going to be completely inside the superset. In this case, both are the same. Both are same. So there is only one circle, and this one circle represents both sets A and F. So A and F are equal. A and F are equal sets. For equal sets, there is one more way to look at it. We know that every set is a subset to itself, and if A and F are equal, it means that A is subset of F, and F is subset of A. So, in order to show if the two sets are equal or not, then you can also use this thing. If A is a subset of F and F is a subset of A, if it goes both ways, that A is a subset of F and F is also a subset of A, it means they are equal. Then A and F are equal. A and F are equal. So this is about Venn diagram. Now in the next video, I will start set operations, union, intersection, set difference, symmetric difference, complement. Okay, thank you very much.